Hello everyone, welcome to JavaScript-Crown today. We are delving into one of the most popular Facebook interview questions, which is available in Leetcode website also. The two-sum problem. In this scenario, we are provided with an input array and a target value, let's say 11. The goal is to find two values in the array that sum up to the target and return the indices. So, for instance, given the array 1, 3, 7, 9, and 2, and the target 11. The value 9 and 2 add up to 11, and their indices are 3 and 4 respectively. Therefore, our desired output is 3 and 4. Let's solve this problem. The most intuitive way to solve this problem is to check every combination of two values. We start with 1, then move to 3, 7, 9, and 2, checking each combination. Start from first element and calculate the sum of 1 with every other element to see if the sum is 11 or not. So the sum of 1 and 3 is 4, which is not 11. 1 and 7 is 8. 1 and 9 is 10. And 1 and 2 is 3. So 1 is not one of our results. We continue with 3 and check every combination after that and see 3 and 7 is 10, 3 and 9 is 12, 3 and 2 is 5. Then we check every combination for 7, and afterward the sum of 7 and 9 is 16, 7 and 2 is 9. And then for 9 and 2 is 11. So the indices 3 and 4 is our answer. Although this approach works, it's not the most efficient. It's essentially a brute force approach, and in terms of time complexity, in worst case scenario, we check n element for each n element of the array. So the time complexity equals to O(n) squared, which may not be ideal for larger data sets. Now let's explore more optimized solution using a HashMap. Instead of checking every combination, we leverage the fact that for each number, we're essentially looking for its complement, the difference between the target and the number itself. For example, we subtract 1 from 11 and the result is 10. And 10 doesn't exist in HashMap. If a value doesn't exist in HashMap, we just put the value and the index in the HashMap. For example, for the first one, because 10 doesn't exist in HashMap, we add 1 and 0 to the HashMap, and we subtract the second element 3 from the target, and the result is 8, and 8 doesn't exist in HashMap, so we add the value which is 3 and index into the HashMap. And then for 7, the result is 4. 4 doesn't exist in HashMap, and add 7 and 2. And subtract 9 from 11, and the result is 2. And 2 doesn't exist in HashMap. 9 and 3. And subtract the last element, which is 2, from the 11, and the result is 9. The 9 exists in the HashMap, so the result would be the index of 9, which is 3, and index of 2, which is 4. In a nutshell, we iterate through the array, checking if the complement exists in the hash map. If found, we return the indices. If not, we add the current value to the hash map. This approach reduces the time complexity to O(n), since we only iterate through the array once. Okay, why O(n)? Consider the big array like this, and for sure there are 2 elements in this array that some of our target we don't know where they are, and when we meet the first element, the hash map cover the value come before that value. We get to the second value and our hash map is going to be this portion. So every value that comes before this, we're gonna be guaranteed that once we visit the second element that sums up to the target, we're gonna be guaranteed that the first one is already in our hash map. So we guaranteed to find this solution. Now, since we only have to iterate through the array once and we're adding each value to our hash map, which is constant time operation, and we are checking if value exists in our hash, which is also a constant time operation, the time complexity is gonna be big O(n). And we are using extra memory. That hash map isn't free, so the memory complexity is also going to be O(n), because we could potentially add every value to the hash map. Space complexity, and this is time complexity. Let's write code in JavaScript for HashMap approach. First of all, we should define HashMap name num_map equal to new map. Then we have to loop through the entire array, so we write for loop for let I equal to 0, I less than nums.length, then I plus plus. Then we define a variable named complement by subtracting the nums_i from the target. Then we should check if this complement exists in the hash map or not. If num_map that has complement, then we return the indices, which are num_map that get complement and I, and if else we should save the value of complement into the hash map nums_i and I. If we go through the entire array and don't find a pair of numbers that add up to the target, we should return an empty array. That's it.